Right, so with this question, you've got this particle moving in a straight line, yeah, and the surface is rough. And the coefficient of friction is this here, mu, of course, for the coefficient of friction is equal to 6/49. Now, there's no talk here of any push force right here, okay? It doesn't say that there's a horizontal force applied, okay? Just saying that it just says that it is moving, okay? Moves in a straight line, and because it's rough, of course, there will be a frictional force slowing it down, okay? Now there's nothing pushing it forwards, okay? So it could be like before, right, before, that it was pushed initially, and it was given the speed when it was pushed, and then that was it, okay? No more pushing. It was just pushed to start with. So now it's going to start to slow down, isn't it? It doesn't come to stop. It doesn't come to a stop straight away, but it is slowing down because of this friction, the force acting. It's the only force acting on the object is this frictional force, just slowing it down until it essentially comes to a stop. So when it says you find the frictional force, well, we can do that because we know when it's moving, of course, friction will be at its max. It'll be working as hard as it can, and that'll be mu r. And the deceleration of the particle. So yeah, slowing down, isn't it? Because this frictional force is actually just bringing it to a stop. Okay, there's nothing making it go faster. We've got the direction of acceleration going this way because that's the way the object is moving. Okay, it is going that way. Okay, but we'll find, of course, even though I've got it going this way, it'll actually come out as a negative answer because we are decelerating. Okay, so first of all, to get the frictional force, we write it as mu r, yeah, because it's in motion. And of course then remember r is the normal reaction, and when we resolve vertically, okay, we could see then that r is just going to equal 3g, okay? Forces up will equal forces down because there's no movement vertically, okay? It's staying on the level here. So r is equal to 3g, which is 3 times 9.8, which is 29.4 newtons. So therefore then we can work out the friction. So that'll be mu, which is 6/49, times then the normal reaction, which is 29.4. So if I work that out at my calculator, I get out to be 3.6, okay, newtons. Okay, deceleration then, well, when we apply then Newton's second law, okay, in the direction of motion, okay, so we apply it in the direction that this object is moving in, you'll appreciate there's no forward force. Okay, so remember we did resultant force equals mass times acceleration. There's no forward force here, so it'd be nothing take away the resistant force. So it'd be nothing take away the friction. We end up having minus the friction. Okay, you can put 0 there if you want. You can do that if you want. There's no forward force, take away the friction, and that will equal then mass times acceleration. So the mass is 3, acceleration then we want to work out. And of course we know the friction, the value of the friction, the size of it is 3.6. So we can sub that in. Of course 0 take away is just going to be take away friction. 3.6 equals 3a. And therefore then you're going to have a will equal minus 3.6 divided by 3, which of course then is 1.2 or negative 1.2 meters per second. Okay, so we could say that the particle then, because we've got a negative, we could say particle, okay, is decelerating at 1.2 meters per second squared. Notice I haven't put minus there then because it identifies the fact that it's minus by saying decelerating. Okay, part B then, it says the speed of the particle, okay, look at part B here, the speed of the particle at point O is 9 and it comes to rest at point A. Calculate the distance OA. So this brings in our equations of motion, yeah, okay, because if you look here, this is the speed originally is 9, so we can say like u is equal to 9, and it comes to rest. So if it comes to rest, then the final speed, of course, will be at rest, so final speed will be 0, and we want the distance, okay, the distance, so distance is s, of course, that's what we want. But what's good is, of course, we know what the acceleration is, yeah, from here. Okay, so, you know, if you struggled with part A, you could still answer part B, couldn't you? Because we can use this value here. But remember, deceleration, so when I write it as acceleration, I need to put minus 1.2. What's the value I had out here? Yeah, be minus 1.2. You need to use that to show that it's decelerating. And because it's a constant deceleration, I can use the equations of motion. So using v squared equals u squared plus 2as. Well, we know v is 0, u is 9, so that'll be 9 squared plus 2 times minus 1.2, acceleration 2a, and then times the s then. So that would be 81. That would be 2.4 times s. Take that over, 2.4 s equals 81. So then s will equal 81 divided by 2.4. We can get that answer out to be 33.75 meters.